We experience time as a slightly messy construct. The Earth travels around the Sun, while the Moon circles the Earth, and those two orbital schedules do not overlap neatly. This diagram compares our two baseline measurements. On the left is a solar calendar month, which spans up to 31 days. On the right is an actual lunar cycle, from full moon to full moon. That takes exactly 29.5 days. Because of this half-day difference, if a full moon occurs exactly on the first day of the 31-day month, the subsequent full moon will complete its cycle and appear again on the 30th or 31st. Our modern calendar is an ongoing, mathematically awkward compromise. We are constantly forcing the moon's rigid 29.5-day pace to fit inside the solar year's boxes. This timeline represents a full 365 days solar year. To see how these schedules interact, we have to scale the math up from a single month. If we stack 12 individual lunar cycles together, multiplying 12 by 29.5 days, we get a total of exactly 354 days. That gives us the precise length of a lunar year. Look at the gap at the end of the timeline. What is the exact difference between the 365-day solar year and the 354-day lunar year? The lunar cycle falls exactly 11 days short of the solar calendar every single year. This invisible 11-day gap is the mechanical cause of our calendar anomalies. It creates a mounting mathematical pressure that the calendar eventually has to release. This multi-year timeline tracks what happens to those leftover days. The mathematical pressure continues to build. The 11-day drift from year 1 is added to the 11 days from year 2. By the middle of year 3, the stacked remainder finally surpasses the 29.5-day threshold required to generate a whole new lunar cycle. This accumulated remainder forcefully squeezes a 13th full moon into our standard 12-month calendar roughly every 2.5 years. This split-screen graphic shows how we interpret this anomaly today. On the left, we see the modern cultural definition of a monthly blue moon. This occurs when the extra cycle lands perfectly inside a standard calendar month, resulting in 2 full moons within that single calendar window. On the right, we have NASA's strict astronomical definition, the seasonal blue moon. This refers specifically to a season that contains 4 full moons instead of the usual 3, with the third moon isolated and given the title. The blue moon has nothing to do with the physical color of the sky. It is simply the calendar's mathematical pressure release valve for the accumulated 11-day drift. Tracking this discrepancy is an ancient human practice. Thousands of years ago, the citizens of Corral built distinct tracking systems into their stone structures to manage this exact drift and monitor the lunar phases. Despite the precision of modern digital calendars, major global traditions still relied heavily on the rigid 29.5-day cycle to navigate the solar year. The dates for shifting observances, like Easter or the Islamic month of Ramadan via the Hijri calendar, remain entirely dependent on these precise lunar calculations. This summary chart outlines the formulas. A lunar cycle is 29.5 days. A lunar year is 354 days. The solar year is 365 days. The annual drift is 11 days. And the result is 1 extra full moon every 2.5 years. Mastering the 29.5-day cycle strips away the folklore, exposing the precise, predictable gear that drives our planetary clockwork.